But why does DeepSeek include this? The development is very challenging. Engineers have to put in a lot of effort. Maintenance is also demanding. What are the essential requirements for engaging in high-frequency trading? It's about the need for computing resources, and DeepSeek has many engineers with that background. Hello everyone, this is Era from the Pacific, dealing with the waters of DeepSeek. There are still many questions arising because the curiosity isn't fully resolved. Tom's Hardware, a famous tech magazine, mentioned something interesting. What is DeepSeek's AI breakthrough? They managed to bypass Nvidia's CUDA framework entirely. So, what were they able to create with this method? They opted to use Nvidia's assembly-like PTX programming instead, sparking debates about whether Nvidia's CUDA supremacy is finally being challenged. Many are questioning if this is merely a misconception, or if Nvidia is genuinely facing a decline. Since I've received such questions, I'll summarize the related content for you. First, although many of you are already familiar with CUDA, let's review it once more. CUDA is essentially a GPU created by Nvidia. Consider it as a platform designed by Nvidia for parallel computing. Although CUDA includes a core hardware component within Nvidia GPUs, it fundamentally serves as a software platform. This might sound a bit ambiguous when we refer to it as a platform, but it essentially empowers developers to efficiently program AI and GPU-related applications. This is supported by the Nvidia developer site, which provides a wealth of resources and tools for developers. Nvidia provides a site where the code is constantly being upgraded and various features are continuously being updated. CUDA, which stands for Compute Unified Device Architecture, is specifically designed to optimize Nvidia's hardware for AI functionalities and development. This has led to discussions about its potential benefits when attempting to leverage other GPUs. In essence, the primary advantage of GPUs over CPUs is their capacity for parallel processing. This architecture's support for parallel computations enables the use of CUDA to simplify specific programming tasks and control the hardware. Moreover, it provides an extensive range of libraries to enhance AI performance. As highlighted on the Nvidia blog, the technologies we utilize are often the same ones consumers use online, like for speech applications. You can use AI in various ways, like translation recommenders for speech or translation tasks. In business, AI can be applied in healthcare, bioengineering, manufacturing, finance, and banking. For supercomputing, applications include molecular analysis and weather forecasting. To support these applications, you need to know which apps and frameworks are available. Consider widely used tools such as TensorFlow and PyTorch. These tools interface with Nvidia's CUDA libraries to fully utilize the capabilities of their GPUs. This integration facilitates various operations, including machine learning, deep learning, and language processing tasks. Therefore, Nvidia is not only working on hardware design, but is also preparing applications that can accelerate GPU performance. This means that the company is creating a foundation that allows countless developers to more easily build AI applications and a variety of other software solutions by optimizing the hardware's capabilities to the fullest extent. In this instance, DeepSeek has opted to bypass CUDA entirely, choosing instead to leverage a programming approach known as assembly-like PTX. Assembly language, which is considered a very low-level form of programming, can be quite complex and difficult to understand. To put it in simpler terms, it's like asking ChatGPT, "Hey, what are you up to?" When you inquire about DeepSeek, asking "what is this?" it responds in a manner that is remarkably similar to human language, despite being a machine. This characteristic makes it a high-level language. In contrast, programming in a more straightforward way, closer to the machine's understanding of binary codes, is considered low-level assembly language. DeepSeek engineers. Instead of utilizing high-level AI libraries like CUDA, the strategy here involves optimizing at a very hardware-centric level, using a language akin to assembly. This approach circumvents CUDA to achieve optimization, which is the crucial point. So, what exactly is PTX programming? PTX stands for Parallel Thread Execution, hence the abbreviation PTX. Can you see this? Where is it located? It's embedded within CUDA. It's a specific component integrated into CUDA. ISA typically stands for Instruction Set Architecture. To run an Nvidia GPU, while it is possible to compile and execute using programming languages such as C or C++ based on CUDA, they now offer support for an intermediate stage known as PTX before reaching the final machine code stage. Even within Nvidia, this was happening with CUDA. So, when we talk about GPU, you can instruct it using a high-level language to run an AI application or a translation task. But in machine language, it translates to a complex assembly-like code that is not easily understandable. However, you might want to customize it further by working directly with PTX, for instance. Using PTX directly, we call it a streaming multiprocessor. When you examine a GPU closely, you'll notice it consists of various hardware modules known as streaming multiprocessors, SMS, that work concurrently. Similarly, while this concept is also applicable to CPUs, which have various registers and threads that can be executed concurrently, CUDA inherently supports these operations in basic block units. However, by further customizing these settings, you can fine-tune the hardware to function exactly as you need. Imagine going to a burger place and ordering a combo meal, but then asking for 2 extra tomatoes in the burger, no pickles, and 2 additional patties. This way, you can customize it exactly as you want. Essentially, Nvidia includes support for PTX as a kind of intermediary language within the CUDA ecosystem. From a developer's perspective, using a toolkit like CUDA simplifies parallel programming significantly. However, PTX provides the ability to operate much closer to the hardware, offering greater flexibility but also increased complexity. It involves more than just using existing libraries. It requires managing operations and configuring clusters. By adjusting these parameters, they can optimize memory hierarchy at a very low level, deciding which memory to use and how to manage it. DeepSeek has achieved this level of optimization. This allows them to fully customize internal GPU components like registers and streaming multiprocessors to run their AI models exactly as they want. Here, you can see the multiprocessor. Instead of using the standard CUDA library to manage registers and data transfers, you can fully customize these operations to your liking. This makes development considerably more challenging. Each time a modification is needed, you must manually update every single component. Nvidia updates CUDA with every hardware change. This ensures continued support for the CUDA library. That's why there are so many CUDA developers worldwide. If you use that, it can be built easily. But it's worth considering why DeepSeek includes this. The development difficulty is extremely high. Engineers have to put in a tremendous amount of effort. Maintenance is also costly. Ultimately, this means you have to use Nvidia GPUs. It operates at a very low level based on Nvidia-supported PTX. This implies that using hardware from AMD or Intel is not feasible. Essentially, to achieve higher performance, significant time and financial resources must be invested in low-level programming. Generally, developing at the PTX level is quite rare and is typically reserved for very specialized scenarios, such as creating AI applications based on GPUs. Although numerous developers utilize CUDA, those aiming for service deployment or seeking to significantly enhance performance often resort to PTX programming for deeper optimization. They adjust Nvidia hardware to function beyond its default CUDA operations. Naturally, this customization implies that future updates might require additional modifications. Even though updating and re-implementing can be inefficient, it still enhances performance. This applies to those involved in HPC, supercomputing, fluid dynamics, and weather simulations, who aim to improve performance. Furthermore, it is widely utilized in connection with DeepSeek. The engineers at DeepSeek were quants, and Highflyer is the parent company of DeepSeek. It's an AI quant company, and I heard the CEO makes a lot of money. You know my favorite explainer, Tabor, right? As a former Africa TV broadcaster, I have great affection for YouTube streamers. We share the same hometown, so I would love to meet them someday. Anyway, Tabor once explained it. Do you know what high-frequency trading is? HFT, or high-frequency trading, is about buying and selling stocks in huge volumes. As AI computing has advanced, for example, in stock trading, you analyze charts. It's called helping. When there are stocks like these, if you look at them minute by minute or tick by tick, AI can automatically determine their ups and downs. DeepSeek does this, and their parent company has made a lot of money this way. Companies like Citadel are also known to use such algorithms based on chart analysis, but don't ask me about stocks. Ask someone else. This is what I want to talk about. Even for such high-frequency trading, which involves buying and selling through stock chart analysis, what do you think is needed? It means that computing resources are urgently needed. DeepSeek has many engineers with such a background. If there's even a 0.1 millisecond delay in their hardware, it could prevent them from buying or selling quickly when they need to, leading to significant losses over time. Conversely, if they properly support computing, they could make a tremendous amount of money. From this perspective, it can be inferred that their goal was to reduce latency by going beyond using Nvidia-supported CUDA and reaching the PTX level. Moreover, considering that they used PTX, it is said that DeepSeek built 2048 units with the Nvidia H800 GPU. The number of parameters is a mixture of experts. As a result, they must be interconnected to train a model with 671 billion parameters, necessitating constant communication among them. Given the H800's limited interconnect bandwidth, it's highly probable that they optimized it to squeeze the maximum performance out of this bandwidth. Consequently, this PTX framework. Although this approach is not the most efficient, it seems they managed to boost performance through some sophisticated engineering techniques. This kind of method has been widely used in high-frequency trading in the stock market, which leads to the assumption that similar strategies might have been employed here. Experts on platforms like X have been discussing this topic. Those who claim that CUDA is obsolete might not be fully comprehending its significance. CUDA serves as a crucial bridge for interfacing with Nvidia's GPU hardware, whereas PTX functions similarly to GPU assembly language. To illustrate, if CUDA is a high-level language written in C, PTX resembles a low-level machine code. This approach is intended to enhance performance. Now, you might wonder if all big tech companies are leveraging PTX for everything. However, for most engineers, particularly in the United States, directly handling PTX is highly inefficient. Manually configuring and operating each hardware component to achieve optimization is both intricate and time-consuming. There are certain specialized fields where optimizing performance and reducing power consumption is feasible. Nevertheless, implementing this across the whole AI platform is quite challenging. The expenses for labor, time, and maintenance are significantly higher. While it is possible to optimize a fixed AI model using PTX to lower power consumption and enhance data center efficiency, it's important to remember that PTX itself is a programming platform provided by Nvidia. For example, DeepSeek utilizes the H800 architecture. When connecting multiple elements, bandwidth becomes limited. To increase data transfer rates, we optimized PTX at a low level. This resulted in a few to several tens of % improvement. In my opinion, it's reasonable to see this as an unavoidable choice for efficiency. DeepSeek operates on a tick-by-tick or minute-by-minute basis, leveraging extensive AI quant engineering experience. This is why it might have been easier for them to handle such tasks. So, when new models continue to emerge, the question remains whether they can keep using these methods. You can certainly keep using it, but it's important to grasp the efficiency aspects, especially since it runs on Nvidia